Okay, so I'm just going to explain the difference between an average rate of change and an instant rate of change, and then how can we get an instant rate of change. So an average rate of change, this is like grade 10 work, so we can find the average rate of change by finding the change in y over the change in x. So on a graph, for example, if I wanted to find the average rate of change between 1 and 2, what I'm thinking about is how much does y change on average with respect to x. So, I can find my two outputs there, 1 and 4, and then there are my two inputs, and then I can get the difference in x and the difference in y. And then that should just give me my rate. The average rate of change from 1 to 2 would be 4 minus 1 over 2 minus 1, which is just saying that on average the y value goes up 3 for every x value. Okay, and this is represented by the slope of a secant line. So if I average those y values out, I get a straight line. And the slope of that line is 3. So I'm averaging out the rate of change. Okay, so we're going to use that to find the instant rate of change. So for the instant rate of change up my color here, we've now hit calculus. So what we want is to find the rate at a single value instead of between two x values. So I'm going to pick an x value, and then my y value will be f of x. Now, I put it on this graph x squared so that you could imagine that this is at 2 and 4 or at 3 and 9. But I want to keep it general so that I can find out more like a formula that's going to work for all functions. So then what I'm going to do is I'm going to pick a second point because I need 2 points to find a slope, so like the secant line. But instead I'm going to take my x value and add a small amount to it. So maybe you want to think like picking 2 and then adding 2 plus 0.01. And then maybe thinking 2 and 2 plus 0.001. See how that would be a better and better approximation of a tangent line? And so then my y value is going to be me putting in that 2.01 or 2.001. So the secant line between these two would give me, this formula here. And what makes it a tangent line is that I let that h value approach 0. So I take the limit as h gets closer and closer to 0. And then this will give me the slope of the tangent line, which is called the definition of a derivative. And it nicely cleans up here because, if you're going to take 2.01 minus 2, you can see the x's are going to cancel out, and so you're just left with h on the bottom. Okay, so this is the definition of a derivative. But alternately, we could have looked at an alternate definition, and I'll show you. Oh, I don't show that. So I'll show it up here. Alternately, we could have picked, instead of choosing f of x, we could have picked a, and then a new point x, and then we would have had f of a and f of x, and we could have made these approach each other. So if we were to do that, we would get this alternate definition where the y values are f of x and f of a, and the x values are x and a, and x is approaching a. Okay, so instead of adding a small amount to the first point, I could just pick 2 points and take the limit as they approach each other. Now, the different definitions cause different things to happen algebraically. So you kind of get a different algebraic method depending which one you use. So I'll just show you a quick example here. Either way, both of these are the definition of a derivative. They find the instant rate of change at an x value or the slope of the tangent line drawn at x. So these are, all different ways to sort of say the same thing or to say what this is giving you. So let's take a look at a quick example. Let's say we want to find the derivative of f of x equals x squared at x equals 2. So at 2, okay, the y value is 4, and we could draw a tangent line. So the point of tangency would be 2, 4, okay, and we can find the slope, which is going to be 4, but I'll show you how to get that. So you could use the definition of a derivative or the alternate definition, and hopefully you'll be able to see how the algebra looks a little different. So we're going to put, we're finding it at 2, so we're going to put 2 plus h in and 2 in and evaluate. And then over here we're going to put in f of x and f of 2. So we're going to leave the x as the point that we're pushing towards the 2. And here we're taking 2 and we're adding a small amount h to it. Okay, so when I put 2 plus h into the function, which is right here, I get 2 plus h squared. And then when I put 2 into the function, I get 2 squared. And then when I FOIL that all out, I get 4 plus 4h plus h squared, and then minus 4. And then my 4's cancel. And then I can factor out an h, and my h's cancel. And the h's are the problem, right? Because you're dividing by 0. And then now I can evaluate the limit, and I let the h be 0, and then I get the rate of change is 4. Okay, and alternately, if I put x into the function, I get x squared. And if I put 2 in, I get 4. And then I have, a 0 over 0 limit. So I can factor the top, and I get x minus 2 and then x plus 2. And then this cancels with a factor on the bottom. And then I let x approach 2, and I get out that the derivative is 4.